270. Those are the places where the tangent is undefined. So if we have a tangent problem with a 90 or a 270 in it, then what's our workaround? What do we do? Change it to sine over cosine. Okay. Now, today we are going to do the same thing with a new set of identities. And the new set we're using are what are called the double and half angles. So we are going to do, today we're going to talk about formulas for twice the angle and half the angle. So you will see on 5-4 notes that I have written down, I'll just pick one, sine 2x. And the formula for that is 2 sine cosine. Okay? Easy enough. Now, where did that come from? Well, I'm not going to prove them all, we don't have time, but I'll show you where this came from, where they all came from. Would you agree that 2x is really just x plus x? And yesterday we learned, think of that as your alpha and your beta. Yesterday we learned that the sine of alpha plus beta is sine of the first, cosine of the second, plus cosine of the first, sine of the second. Remember that from yesterday? Well, these two are exactly the same. So when I add them together, I get 2 of them. This is called the double angle identity for sine, the sine of double the angle. All of the double angles formulas came from doing this very thing. All right, now the one I want to talk about specifically is cosine. Only because the identity for cosine 2x is cosine squared minus sine squared. That's what you get if you do this with the cosine formula. But cosine squared is special. Cosine squared is 1 minus sine squared. So this identity, the main one, is this one. But it's also 1 minus 2 sine squared. Would you agree with that? That would be another version of it. And similarly, if I think of this as 1 minus cosine squared, it will become 2 cosine squared minus 1. So I just want to call that to your attention because depending on the problem, one of these may be way more convenient to use than the other. If the problem is doable, it will always be doable with any of them. It's just using this one might be 2 steps and doing this one might be 5 steps. It's a matter of, like, what do I want to say, efficiency. But all of these are identities for the cosine of 2x. Lucy?
Can you explain how you got the 2 cosine squared of x minus 1 again? I don't understand.
How I got what?
The 2 cosine squared of x minus 1.
Change this into 1 minus cosine squared. So cosine squared minus 1 plus cosine squared is 2 cosine squared minus 1. Now, I just did problem 1. I didn't realize it till I just looked at it. But I just did problem 1. It's right there. Think of the 2x as x plus x and use yesterday's formula. So problem 1 is done. Alright, so this is problem 1. I just did it. I did 2x into x plus x. There it is. Alright, now I gotta do problem 2. What's your thought about this? What do you think maybe would be a good idea?
So
cosine alpha plus alpha squared.
Do you think of anything when you see that? Does anything pop into your head?
Difference of squares.
Difference of squares? So how would it factor if it's the difference of squares?
Cosine squared minus.
Cosine squared minus sine squared and cosine squared plus sine squared. Woo-hoo-hoo-hoo. What about that?
1.
That's a
So we're left with just cosine squared minus sine squared. And I know you just saw it for the first time, but isn't that one of my 2x identities for cosine? These are also on your little half sheet.
Wait, what cancels?
Oh, that's just one.
That's one.
You get difference of squares. Oh, wait, that's
Now, this is also the difference of squares, but why would I do that? My job is to end up with this. Isn't that what this is? Yeah, so I know I could factor this, but it doesn't serve my purpose this time. I want to end up with cosine 2x, and that's what this is. This is cosine 2x. Now here are the half angle identities. So sine, cosine, tangent of half the angle. And the tangent half angle appears in a couple of different forms. And again, which form you use ultimately doesn't matter. It just makes life a little easier sometimes if you use one or the other. Okay, so let's find the sine of 15. We did this yesterday. How did we find the sine of 15 yesterday?
60 minus 45.
45 minus 30, or 60 minus 45, or some other combination we came up with. That would be called, I would say that, find the sine of 15 using a sum or difference. That's 60 minus 45, that's a difference. This says using a half angle. So what's 15? 15 is half of 30? Don't look at me like a deer in headlights. 15 is half of 30. Okay, now what does my formula say about the sine of half an angle? This is like your theta. It's plus or minus the square root of 1 minus cosine 30 over 2. Our theta is 30, right? Because 30 over 2. All of these half angles with the radical, going to the versions with the radical, all have a plus or minus in the front. Now sometimes that can be problematic, but not in this case. We're finding the sine of 15. Is the sine of 15 going to be a positive number or a negative number? Positive. Where's 15? Quadrant 1. Won't that be positive? So I'm going to skip the plus or minus. I know it's going to be positive. The plus or minus is part of the formula. You have to think about it every problem you do. But if you know your angle is 15, then you know it's going to be positive. All right, what's cosine of 30?
Root 3 over 2.
Root 3 over 2? So I'm going to have 1 minus root 3 over 2 over 2. This maybe is the first time you've ever had radicals under radicals. I'm not sure. It's no big deal. It's no big deal. I mean, it's not nice, it's not pretty, but it's okay. It's not okay, whoever said that, it's not okay to have fractions within fractions though. So I'm going to times everything by 2, and that's going to do 2 really cool things. It's going to give me 2 minus root 3 over 4 times 2 times 2 times 2. And what's so cool about that? The denominator now is just 2. And the top is whatever it is. We never have issues with radicals on the top. That's not the problem. The problem is radicals in the bottom. But since that turned into a 4, it's easy. Yeah.
Is it?
Oh, it's out.
That's what you would do if you were gonna simplify it.
Yeah.
But we really, according to Mr. Shadio, only do it, only, no, AP doesn't require it. Unless it's a root 2 or root 3, then we do it. All right, now, I know what I'd be thinking if I were you. Mrs. Ford, that does not look like any answer that I got yesterday. Okay? So here's what I want you to do. Real quick, I want you to type this number into your calculator and get a decimal. While you are doing that, I'm gonna do the problem the way we did it yesterday. With 6, oh wait, this is sorry. So would you get a decimal for that? When we did the problem yesterday, do you remember looking, we maybe didn't do this exact one, but do you remember what we did yesterday, kind of looking like that? And this is what that answer would come out to be. Type that into your calculator. And guess what's gonna happen? They're going to be the same. They're going to look different, but they are the same. And you could make them the same, I'm not interested in doing that right now, we gotta keep going. Okay? We're finding the sine of 15 degrees without a calculator.
Oh,
The
I
exact
see.
sine of 15. Oh, is that?
So we're not actually finding like the half angle of 15 on values that we get is the half.
We're finding the sine of 15, that's the problem. We're finding the sine of 15 degrees. Press sine 15 on your calculator. I'm assuming you're in degrees.
After fighting
And it better be the same, we just got decimal right here.
Yeah. So it's
Oh, screw it.
So, here, we found, okay, stop. Is 15 one of our special angles? No. So we found the sine of 15 anyway, by here, thinking of it as half of 30, and here as thinking of it as 60 minus 45. Both of those are options for you. In this case, the directions told me do it with the half angle, so I did it as half of 30. But if I'm walking down the hallway and Mrs. Hollis says, hey, find the sine of 15, I can do it either way. They're both right. Next. Tangent 7 pi over 12. What is 7 pi over 12?
girl. He's so. Should have given me the wrong address. Oh, it's 150. 105. 210. Well,
I'm hearing all kinds of crazy.
150 degrees.
It's not 150 degrees. 7 pi over 6 is 150 degrees. No, 5 pi over 6 is 150 degrees. This is 7 pi over 12. What did you say it is? He says it's 105. How does Peter know that 7 pi over 12 is 105? Pi is 180. Right? So this is 7 180s divided by 12. He said that's 105. Now, using a half angle identity. I know I could do this problem the way I did it yesterday by adding 60 and 45. That'll work. Other things will work too, but that's one that would work. I need a half angle. So 105 is half of what? 210. So I am gonna find the sine, or excuse me, the tangent of 210 divided by 2. Now, you have an option. The first one looks kind of scary to me. How about if we use the second one? If we use the second one, and any of them will work, I don't care which one you use. I'm being lazy and saying the second one looks easier than the first one. So 1 minus cosine over sine. What's my theta? 210. So 1 minus cosine 210 over sine 210. All right, I need 210. When you look at my picture and tell me if that looks like 210.
Yeah.
So, what's the cosine of 210?
Negative root 3 over 3.
So, negative root 3 over 2 is the cosine of 210. Divided by, what's the sine of 210? Negative 1/2. Everybody in agreement with that? Kind of a mess. Let's times it all by 2. So what am I gonna have if I multiply everything? Hey, let's use negative 2. If I multiply everything by negative 2, I'll have negative 2 minus root 3, because I already have a double negative, and I'm throwing in another negative, and then my denominator is just 1, so there's your answer. Now, experience matters. I used my experience on this problem. Could I have chosen the third option? Okay, can you think of a reason, looking at the situation, can you think of a reason why the second option really was the best one to use in this case?
No square root in the
No square root in the bottom. If I use the third option, then my denominator would involve a cosine. And what's the cosine of that angle? Root 3 over 2? So then I would have had a radical down there, but this way I didn't. So do you see what I mean? Why it's easier sometimes to use one form than the other? And you might want to draw your picture and look at the numbers before you pick which one. I was thinking ahead because I've done this 100 times. Okay. All right.
Do you have to memorize these formulas?
Well, see, this is where you guys just totally luck out. Because hardcore Mrs. Ford says they need to be memorized. Beautifully kind, wonderful, generous Mr. Chavio says, let them use their sheet. So, we use our sheet. All right, we're gonna do one more problem. One more problem, and then I'll do a couple of identities. Okay? All right, so here we go. Number 4. Cosine is 3/5. X is between 270 and 360. And I'm finding the sine of x over 2. There's the problem. Tell me what has entered your head.
The hypotenuse.
What's the
Hypotenuse.
Oh, it's like, no, that can't work.
Quadrant 4, doesn't this mean that my angle X is in quadrant 4? Okay, good place to start. What does that tell me? Adjacent is 3 and hypotenuse is 5.
4.
Pythagorean theorem would tell me this is negative 4. Negative 4. Isn't this a formula? So here we go, plus or minus the square root. You don't have a choice on this one. That is the only formula. Tangent, we have a choice on, half angle. All right, so plus or minus 1 minus cosine over 2, am I right?
Could you plug 3/5 in?
So now I'm going to plug in 3/5 for the cosine. That's what the cosine is. So 1 minus 3/5 over 2. Because that's the cosine. I didn't even really need my picture because they gave that to me.
Wouldn't it be negative?
Let's times by 5. So I have 5 minus 3 over 10. Would you agree with that? Timesing everything by 5. So that's the square root of 2/10, or the square root of 1/5, which I can't help myself. That's 1 over root 5, which is root 5 over 5. Would you agree with that simplification? It's an easy one that I just can't help it.
And then we keep our plus or minus here?
No.
No.
You need to pick which one it is. So before I talk about that, I want to make sure everybody is with me here. This is where I am so far. Are you with me to this point? Okay, now, the first problem we did today, we had to pick plus or minus. Anytime you're using one of these formulas, you ultimately have to choose. The first one we did was easy because the angle was 15. First quadrant, positive. That was easy. This time, the angle is unknown. The angle is X. And what I want to caution you about is, somebody said, well, wait, I'm sitting down here in quadrant 4, and I'm finding the sign, won't the sign be negative? And that's true, except I'm not finding the sign of X. I'm finding the sign of half of X. So if X is between 270 and 360, half of X is between 135 and 180, which means this angle, the one I'm finding, is in quadrant 2, and the sign is positive in quadrant 2. Wow, that's crazy. But yeah, you gotta think about all that. The only time you have to think about a sign, to get my final answer, is these formulas that have the plus or minus. If you were using a different formula that didn't have a plus or minus, then whatever the answer came out to be would be it. Like yesterday, root 6 minus root 2 over 4, that was it. But every time you use one of these radical formulas, you have to pick one or the other, every time. Okay, did you understand why my thought process, why that's positive? All right, that's enough for that today. We'll stop there. And I want you to get out the extra practice identity packet I gave you. We are going to be having a quiz, and you're going to have to know these.
You didn't need to correct all of that. water bottle.
So let's practice.
Hey, I cannot find. Someone help. What is this?
Alright, so the one right on top says this is Christmas gift.
Oh, is this for first semester?
Well, back in the days when I saw my students every day, this was first semester. Now it's February.
I can't.
Alright, so I'm just gonna pick one. I like number 7. It just looks kind of cool. So I'm gonna do it.
Identities. Christmas gift.
So I'm on the Christmas gift paper, which is the very first one.
Which number?
Number 7. And I'm looking at this, and tell me some things that are going through your head. Because I want to spend like 30 seconds thinking about this before I jump in and start doing stuff. What's going through my head?
Change your tangents to sines and cosines.
Alright, so one thought is, change your tangents to sines and cosines. Now, again, see that right there? What does that mean? It's all gotta cancel. And that means it's all gotta be like terms, right? Tangents aren't gonna cancel with cosines, right? So let's think about that, okay? What's another thought that might enter your mind?
They have to equal each other.
This actually could be reduced because I know sine squared is 1 minus cosine squared, which factors and cancels. That would clean that up a little. So let's go with those ideas. I like those ideas. So sine over cosine over sine over cosine plus sine minus, I'm gonna wait on this and see what happens on the other side here. I like that idea a lot. I like that idea, but let's see what happens over here. What shall I do?
Multiply by cosine.
Multiply by cosine. Now, kids, I only have to do this fraction. That is a separate fraction, so you don't have to multiply that one. If I'm gonna add these together, I need a common denominator, but in terms of simplifying this fraction, it's a totally separate problem from that. So what have I got here? Sine over sine plus sine cosine.
Factor a sine.
So down here I can factor out a sine. And notice then, I'll be left with 1 plus cosine. And remember when somebody right away said, let's change that into 1 minus cosine squared? Because then I'll have 1 over 1 plus cosine minus 1 minus cosine over 1 plus 1 minus.
I'm not really.
E period. Econ. Oh wait, no, it's G period.
Do these cancel?
Studying for
Leaving me with a 1 up here. So what have I got? 1 over 1 plus cosine minus 1 over 1 plus cosine, which all cancels out and makes 0, which is what we want. Alright, we'll do one more. Pick another one off that page. We'll just stick with this page. Pick one, I don't care.
Yeah, I
here we go, number 11.
Oh, I didn't actually.
I'm on the same sheet doing number 11. Good grief.
This is for, can I use a dry erase marker and do it on the desk?
You can do whatever you want.
Can I borrow one?
Okay. I think we have. I thought about this one. Caution. You guys are all really, really smart, but don't overthink it. Look at what we have, particularly these first two terms.
You just flip.
Could we just split this apart, kind of uncommon denominator it? And won't that take care of the first two terms? Because this is just cosine, and this is 6 over cosine, which is 6 secant. And now all I need to do is worry about that. So, what about that? What should I do with that?
What's that? Cosine.
Change cotangent into cosine over sine, but it's still all over cosine. Would you agree with that? So if I times by sine, since that's my common denominator, I'm going to be left with what? I'm going to be left with 7 cosine over cosine sine. Are you keeping up? What's that? 7 over sine, which is 7 cosecant. Okay? So again, you're just starting. I get that. You get frustrated. I get that. But try to keep an open mind and always keep an eye on what you want to end up with. We could change everything into sines and cosines and have a big mess over here. We don't need to do that. You can, and eventually it'll work out. And you got time for one more. That went quick. Another one from this page. Hurry.
Oh, we just hit?
Yeah.
12.
12.
Ample amount of space.
All right, number 12. Here we go. Well, this is kind of weird. It's got a random theta floating around in it. All right, tell me what you think. What in the heck should we do here?
I
Change the
don't get it.
cosecant squared into 1
Oh, that's a good thought. She says, look what I want. So what if I took this guy right here and changed him, okay, I always have to write it down. 1 plus cotangent squared is cosecant squared. So change that into 1 plus cotangent squared. That guy right there. That's not a bad idea. When you looked at this, did anything pop into your head?
You can flip that into like a tangent, cosine, whatever, and then they'll cancel out. And it
Exactly.
leaves you with tangent.
That exactly.
So
Because
tangent
secant is 1 over cosine. So what happens when you multiply
sine
these
over
two
cosine.
together? You get sine over cosine, which is tangent.
Oh, that's crazy.
Remember, a secant on the top is a cosine in the bottom. This is sine over cosine. So this is what I have right now. I have theta plus theta cotangent squared minus theta. That's all that's left, because these two guys canceled. Allison had a great plan here. The thetas just cancel, and what are we left with? Oh my gosh, that is so awesome. Good work, Allison. That was a great thought to have there. And how did she know that? She looked at what her end result.